All right. We want to know how high our toy goes after you overpull it and it comes flying off of the spring. So we know some information about mass spring oscillators and the fact that it is going to be moving at its maximum velocity at its equilibrium position. Because it was released at its equilibrium position, we can look at the fact that that Vmax is happening there. So we saw in a bunch of other problems that we've done and in our notes that Vmax is going to be equal to 2 pi f times our amplitude. Your amplitude here is going to be how far below the equilibrium position you pulled it. In my case, this is at 33 centimeters or 0.33 meters. The next thing that you're looking at is the fact that you're given the period rather than the frequency. And remember that frequency is equal to 1 over the period since they are inverses of each other. And my period in this particular question is at 0.55 seconds. Once I have this particular bit of information, that maximum velocity, I know that that's the speed at which my toy is going to be actively launched. All right. Well, if we're launching something, you should be going back in time to our kinematic equations. Because we don't know how long the object is in the air or what time it's in the air for, and we are interested in how high above the ground, we are going to go ahead and use our time-independent kinematic equation. As you know, it looks like this. All right, this is not a new equation for you. You've already done that. The Vmax that you've already solved for, that's going to be your initial velocity. All right, this is flying through the air, so this acceleration is going to be gravity. At the top of the path, we know that the velocity is going to be 0. And then this quantity here is actually what you're solving for. This is your h. All right, at this point, you should have enough to go on to be able to solve your answer.